Hi everyone, Mr. Kakmar here with an introduction to how to use Excel, and I'll be doing it through a lab we did recently, the Refractive Index lab. Just a note before we begin. Typically when we plot things, we plot two variables, a control variable that we control, and changes in that control variable will affect the variable we're interested in. For example, for an ideal gas at constant volume, as the temperature increases, the pressure will also increase. So we can plot different temperatures in one of these columns and find how the pressure changes with that. When we plot that, we see a trend. We see graphically as temperature goes up, pressure goes up. With the lab we're doing today, we're going to be plotting data points where we're going to calculate the refractive index value. And since we were all using the same material, we should get just a straight line. This tutorial is here just to get you familiar with some of the basics of Excel and also show you how to plot error bars on Excel as well, which is a little more complicated. So even though our graph isn't going to be typical of what you would have to do in the internal assessment, it is an introduction to how to use Excel. Well, let's begin with what we had to do. So, on the sheet I gave you, what you had to do was you had to record for yourself and for your classmates all of the different angles of incident that I gave you. So each one of these represents the data from one of your classmates. So you would have recorded their angle of incident, what they calculated this, the angle of refraction, and it's called the first angle of refraction. This is the one we're most interested in. And you should all have a second angle of refraction as well. If you did the lab well, with no mistakes and with not a lot of errors with your measurements, these second angle of refractions should be equal to the angle of incident, because these are the angles coming out of the unknown material into air, and these were the angles going from air into the unknown material. So these values should be the same, if not very similar. And then the angle of refraction, or the first angle of refraction, is really the number we're going to use in our calculations to figure out what is the refractive index of the unknown material that we used in the lab. So I'm going to take all of this information and copy it. You can copy by doing Control-C. Take all of this information and copy it and move it into this data table. So now I have some more information. Data point, again, normally this would be our control variable, the thing we're controlling, and then we would have the variable that's changing because of that. But because of the nature of this lab, the data points will, instead of being like temperature, will just be 1, 2, 3, 4, 5. So I'm going to type in 1, 2, 3, 4, 5. Excel has this really neat feature where once you start a trend, and you can see the trend that I want to continue is adding 1 each time. Once you do that a few times, you can highlight those numbers. Take this little X here at the bottom. You can see right here. It becomes a cross, and I can click and hold and drag that down. And you can see here on the side of the little cross, it's telling you what Excel thinks the number you want to put in there is, and it is increasing by 1 each time. So I can actually fill this in much quicker than typing 1, 2, 3, 4, 5 all the way down to 21. Again, with any of these things that you want to see again, just pause the video or rewind the video and watch what I did again. All right, so now we have our data points. We're going to be plotting data points versus the refractive index. Excuse me, that's over here. But the first thing we have to do is, how do we calculate the refractive index of a material? Before I calculate the refractive index, let's go ahead and talk about these two images that I have here on the screen. This is the image you'll typically see in a textbook. You'll have an incident ray, you'll have a boundary between two different mediums, in this case air and our unknown material, and then we'll have a refracted ray. And because of the different speeds at which light travels through these materials, it actually bends. That's what this refracted ray is. But our setup's a little more complicated than that. So let's look at this picture over here to the right. What we have is we have an incident ray coming in, we have it going through the unknown material, and then we have it exiting out. So what we actually have is two of these values that should be the same because it's the same material, it's air on this side as well, and the unknown material is here in the middle. So when we have angle of refraction 1, what that is this first angle of refraction. And as this light exits, again, we have another barrier change here. We have the unknown material above this line and the air below it. We have another angle of refraction, which isn't drawn here. The normal line isn't drawn. We'd have to draw another normal line right here. We could calculate the angle of refraction for this one as well. So this is the one we're really interested in because this one, as I mentioned, should give us the same value as this one. So we want to calculate the refractive index, but we need to know some information first. If we open up our data booklet, we'll see this is the equation we're going to be using, where n is the refractive index of two different substances, and theta is the angle formed between the normal line, the line normal to the boundary between the two substances. And we have that for both of these, both of the substances we're using. So for our example, we have air and we have our unknown material. This is our prism. So the angle we want to use, the angle of incident, is between the normal. This line is normal means perpendicular, is normal to this boundary. So here's our boundary between air and our unknown material. We have already drawn in our normal lines in our lab. We've calculated, or we've written down using a protractor, the angle of incident. I actually gave you this, and the angle of refraction. So if we write our equation that was given in our data booklet, substituting in 1 and r and I and 2, we get this equation. As we all know, the refractive index for air is 1, so we can actually remove this term. So the refractive index for our unknown material is equal to the sine of the incident angle divided by the sine of the refracted angle. Now, in order to use Excel, in order to put in sine and cosine and things like that, it requires a special formula. And a lot of times the formulas are what you would think. To type in sine in English, you would type in sin, and that would bring up sine. Unfortunately, my computer is in Spanish. So to type in sine, I'd actually have to use the Spanish form, which is seno. Now, depending on what computer you have and what software is loaded on it, you might be more familiar with the English version or the Spanish version. I found this great website, which I'll put a link to below in the YouTube video. I found this great website which translates between the English function name, the Spanish function name, and it gives a description. So this way you can look up in Spanish or English things you want to do. So for example, you want to look up sine. How do I type in sine in Excel? This is Excel 2007. I believe this is true for Excel 2007 through the current year, which is 2017. It even tells you here, you can use the function Control F to search. So to search through this web page, I'm going to hit Control F, which is find. You can see down here for Firefox, something comes up. I want to do sine. Let me search for sine. Unfortunately, you can see the first one that comes up is using, so maybe I'll do sine space. And that doesn't show up at all. So let's find sine. Or actually, let's type in the actual word. Sine is S-I-N-E. You can see cosine has come up over here. I want to go to the next one. Here it is, sine. Returns the sign of a complex number. Oh, I don't want a complex number. I just want the regular number. Let's move on. Returns the arc cosine. Not interested in that. Cosine, arc sine, hyperbolic sine. Here we go. Nope, that's cosine. Hyperbolic sine. Here we are. Returns the sine of a given angle. So if in English I want to do sine, and in Spanish I would do seno. Let's come back over here to my page. If I click up here, I see a complicated formula. So let's break it down step by step. Seno means I'm taking the sign of the thing in parentheses. You can see here Excel comes up with a little helpful hint. When you type in seno or sine, the parenthesis, the thing you put inside is the number you want. Now, what isn't clear is whether that number has to be in degrees or in radians. And actually, it needs to be in radians. And the numbers we have are in degrees. So I want to take the sine of my angle of incident, which is 25. For me, that means I want to put in cell B2. You can see B2 is currently highlighted here. So it's going to take the sine of B2 times pi, and I'll explain later in a future video what does the parentheses mean and things like that. But for now, what you need to do is to convert between degrees and radians, you multiply by pi and divide by 180. So we have to take the angle of incident times pi divided by 180. You can see the closed parentheses, which is the end of our number. By doing all that, this will give us the sine of the angle of incident. We're going to divide that by the sine of the angle of refraction. And my angle of refraction is in cell C2. Well, what do I mean by C2? Let me come over here. Let me hit escape. You can see each column is given a letter, and each row is given a number. So this cell right here is cell C2. So whenever I click on a cell, the column is highlighted and the row is highlighted. So if I ever want to do a calculation involving this cell, instead of typing in 14 or whatever number is listed here, if I type in C2, Excel's going to know, oh, you want cell C2. So for example, let me come over here and just type in equals C2. If I type in equals C2, it highlights here which cell I'm talking about. And if I hit enter, it's going to give me the value of that cell that I typed in. Well, in this case, I don't want just to write down this value. I actually want to do a calculation with that value. So I want to calculate B2 times pi divided by 180. I want to take the sine of that. So that's what this whole thing here is doing. The sine of cell B2. And again, this is just a conversion factor, pi and 180. And I want to divide that by the sine of a second cell, C2. And again, we have a conversion factor as well. So you can see every cell that I have in my formula here is highlighted by Excel. So it's saying, hey, in this formula you're using these two cells. Is that correct? And the way I have it written is correct. So I go ahead and type that in and I hit OK or enter. And it gives me the value. This is the refractive index of the material. It's 1.75. Well, I want to calculate the refractive index of all these other materials. How do I do that? Well, just as before, if I click this little square here and drag it down, Excel assumes that I want to continue the same formula all the way down. Notice that here I had B2 and C2, which is the same row that I'm in. I'm in row 2. It's saying C2 and B2. Well, what does it assume when I go down one more step? It's assuming that I want to do the same calculation, but instead of doing the exact same cells that I had before, it assumes that I want to use the cells one below those, which makes sense, right? Instead of doing this same calculation for the same 2 points, it's going to say, well, I assume instead of B2 and C2, now that you're doing a calculation in row 3, what you want to do is B3 and C3. So it actually will perform all these calculations all the way through. Let me go ahead and click up here. You can see it's highlighting these two cells that I want to use the calculation for. Or if I go to row 18 and come up here and click on the formula, it's saying, oh, I'm using these two cells, B18 and C18, instead of my original values, B2 and C2. So Excel, in a lot of ways, is smart, and it knows what kind of additional calculations you want to do. And again, the more you use Excel, the more this will become simpler for you to use. I want to go to the next column, uncertainty. We've learned how to do uncertainty calculations. There's a method depending on the tool you're using for measuring and the uncertainty for each measurement. You can propagate that uncertainty. That's one of the ways you can do the uncertainty for a calculation. Another way is just figuring out what is the spread in my uncertainty. What is the value I should have gotten when I did a calculation versus the value I actually got. As I mentioned before, the second angle of refraction should be equal to our angle of incident. If we did all the calculations correctly, not calculations, if we did all the measurements correctly, these two values should be the same. And so one of the ways we can calculate uncertainty is not based on a propagating value based on calculations, but instead calculating the difference between two measurements that should be the same. And since these two measurements should be the same, I can say the uncertainty of my measurement would be equal to one value minus the other one. The value I got, 25.5, versus the angle I should have had, which is 25. So I can just do D2 minus B2. Again, if I click up here, it'll highlight the cells that I'm interested in, that are used in this formula. And these are the two cells I want to use. And as before, I can slide this calculation down so it calculates the uncertainty for all of my values. So here's the uncertainty. Which uncertainty do I want to use? Well, I want to use the maximum uncertainty. So I'm going to do another calculation here, equals the maximum value for a group of cells. So I'm going to click and drag all of these, and this is going to return the maximum value in uncertainty for all of these. Well, I also want to calculate the minimum uncertainty. because maybe my biggest difference happened to be on the other side when I'm subtracting as opposed to adding. It's not the case. The biggest uncertainty I have is 0.5. So the uncertainty I would use for this would be 0.5 in my calculation. So now we're going to graph. We're going to be graphing data points versus refractive index of material. So the first thing you're going to do is you're going to want to highlight both of these columns. The way you do that is you highlight one of the columns, hit the control button, and highlight the other column. This allows both columns to be highlighted at the same time. And I want to insert a graph. So I'm going to come up here to insert. I'll do insert a graph. I'm interested in these dots. This is a scatter graph. So I'll click that. And I've got my graph created. I don't like the location of the graph. I can click on it and drag it around somewhere. I'm actually going to put it on a different page. These are the different pages or sheets. So I'm going to right click on this and go to change location, or here it's move graphic or move graph. So I'll move the graph to a new sheet and I'll name it something different too, refractive index graph. Hit OK, and it's now created on a new sheet. All right. We could say we're done, but we want to actually change some information about this to make the graph more relevant or be able to see information more clearly. The first thing I'm going to want to change is this axis. The axis currently goes from 1.5 to 1.8. This is Excel's best guess at saying what values we want put on this axis, and it makes sense. 1.5 is below our lowest value, 1.8 is above our highest value, and we can see all of our data points. But with refractive index, what we know is refractive index can go anywhere from 1 to a very high number. The lowest refractive index we have is for a vacuum or for air, which is a refractive index of 1. So that actually makes sense for our axis. I'm going to change our axis here to go from not 1.5 to 1.8, but from 1 to 1.8 is fine. You can see I've established it to be 1, and it's automatically guessing these other things. Now there's other things on here too that you can mess with and play with to make your graph look more as you want it to, but I'll leave that for another time. All right, so we have our data points. We have the different students' calculation of refractive index. And please don't think that there's a trend here. Remember, we all use the same materials. We should all have the same value. Depending on how you record it, you might have some points higher here, lower here, higher here. It might just not look like any trend at all. This trend is artificial. It's not really a thing. It had to do with the way I generated my fake data points for this instructional video. All right, so other things I want to change about this. I want to make the dots bigger. I'll come back to that later. I don't like these axes. I don't like that these lines are here because these lines don't really tell us anything. It's just groupings of 5. So I want to get rid of those. I can get rid of the paintbrush, which is it's like an editing thing. And I can change color or style. Actually, I'm not interested in those things. This is what I was looking for. Elements of our graph. I want to change these lines, these graph lines. And I don't want the horizontal, or sorry, I don't want the vertical ones there because those don't really tell us anything. I like the horizontal ones, but I don't want the vertical ones. You can see as you hover over each one of these, it'll change the graph to show you what it would look like if you clicked OK for that. So lineated a tendency line. That would show us something there. I don't want that on there because, again, this is an artificial thing. Error bars, we can't rely on these error bars because they're not calculated necessarily the way we need to for IB. So we're going to ignore that as well, but there's different things. We can also put on labels for these, and we can also title the axes, which I don't want to do for this. But you do want to title axes when you have 2 different variables involved. For us, it's only the refractive index on this side, on the y-axis. So we don't need titles for this. So what do I want to change? I want to change this font. This font's just way too small. Let's go ahead and change that. I can right click on this and do format the axis. I guess I can change it up here as well. Let me just change that to a bigger number, maybe 16. Those numbers look better. I don't care to change these because these aren't actually important numbers, so normally I would for my internal assessment because I'd have 2 different variables here that represented on both of these axes. But since these are just data points, I don't need to worry about that. Let's change the title size from 14 to maybe 24. That looks a little bit better as well. And the last thing I think I want to change the size of these points. They're just a little bit small, so let me click on those. And come over here now. I don't want to format the line. There is no line. I want to format the point. I don't like blue. I want to choose something that pops a little bit more, maybe red. This will be a little bit easier to see. I don't like how small they are. So we can change the size of these data points. Ancho. Let's change the size to something much bigger. 5. Yeah, it's much easier to see. I like that better. So now I've changed some basics of my graph. And for your internal assessment or other labs that you do for me, you're going to want to play around with this and see how can I change this, can I change that, to get it to look the way you want it. All right, let's see. Next, I will deal with uncertainty. The uncertainty, though, I do need to do one more calculation. This uncertainty that I have here is the uncertainty in the angle, but for my graph, I don't want the uncertainty in the angle, I want the uncertainty in the refractive index. Now, the way we calculate that is actually quite complicated for the situation we have because of the relationship between the refractive index and the measurement we have, which is angle. It's a sine relationship. So I'm not going to go over how to relate sine to the angle measurement, but I will do the calculation here, and then from there we'll go ahead and record the uncertainty bars on the graph. So I'll put in uncertainty for the refractive index. I'll just do RI. So I calculated the uncertainty, and I get this number. Notice that sometimes when we do calculations, we get this long-running decimal, and you might have had that actually for some of these other calculations. What you want to do if you ever have that is you want to right-click on the column, and you can format the cell. I'll format the cell to say, I want numbers, because this is a number, and I want just 2 decimals. Since my refractive index here is 2 decimals, which is something I chose before, I want my uncertainty to be to 2 decimals as well. So I'll just do a 2 decimal uncertainty, and it looks a lot neater that way. As before, I can click and drag, and I have the uncertainty of the refractive index. And if I look through here, I can do the max-min thing I did before. If I look through here, I can see that the maximum is 0.02. So that's the value I'm going to use on my graph. Let's go back over to my graph and create the error bars. Plus error bars, but I'm going to hit this arrow here to say more options. Vertical error bars, the error is 0.02 in either direction. And the horizontal error bars, I want to remove actually. Let's see if I can choose that. So if I do 0, what happens? Yeah, they go away if I do 0. So now I have error bars just for the refractive index. And again, when you do your internal assessment, you'll calculate the uncertainty in different ways and add your error bars accordingly. And you'll probably have error bars in both directions. But since the only value we're interested in is the refractive index, which is the up and down, I'm only going to put error bars up and down. Well, that ends our tutorial for today. I hope you learned how to use Excel a little bit. I hope you understand how to do some calculations as well. And in the future, when I assign you to have to graph something, you'll now be more well equipped to deal with that. All right, have a good day, everyone.